Linear probabilistic modeling, the definition and uses in the engineering discipline. First, we're going to define linear probabilistic modeling, or LPM, as a technique that is used to estimate the probability of binary outcomes through linear regression, given an independent variable, mostly when the value of y is expected to have a linear model like the one in the picture. The regression line is created by the equation y equals b naught plus b1 x plus epsilon, where b1 would be the slope of the line of best fit and epsilon would be the random error. It can fall above or below the line, meaning that this model also accounts for error. Now, the uses of linear probabilistic modeling in engineering. The uses in engineering could be for projects that have only two outcomes. These binary outcomes can be, for example, true or false, yes, no, accept or deny. In the engineering field projects, the binary outcomes are usually stated as success or failure, or accept or deny. And the independent variable can be something like temperature or concentration of material. Now, I'm going to give you an example in engineering, more specifically in civil engineering. An example of this could be the production of a reinforced concrete column for a structure that's been tested. We see an example of the total number of columns produced and how many of them have failed the test. We can clearly see that the scatter plot of the data points is linearly related. This means that a linear model can be used to predict future failure rates of the production. The linear regression line, or line of best of fit, accounts for error, and it will give us the equation where we can plot the number of columns being produced and have an approximation and expectation of how many of them are going to fail the test. In conclusion, we see that this model can be used to predict the failure of production and data points that are somewhat linear, but the use of this model is always at the discretion of the engineers working on it, because we have to consider the factors like the risk of or the size of the error. Since the smaller the error, the more accurate the regression line is going to be.